So first we start with the introduction about the topic. First we start with introduction about the topic. So what does probability mean? Probability is an analysis of the likelihood that an event will happen. So probability is, we can say that how much is likely that this event is gonna to happen. This is what we call it probability. So probability is an analysis of the likelihood that an event will happen. We have three different concepts or conceptual approaches for probability. First, we call it classic approach. So probability has three conceptual approaches. First approach called the classic approach, where the ability is computed by finding the ratio of the number of possible outcomes included in event A to the number of possible outcomes included in the sample space. So the classic approach is where the probability is computed by finding the ratio of the number of possible outcomes included in event A to the number of possible outcomes included in the sample space. So it's ratio. Possible outcomes and these things to happen on the possible outcomes in the sample space itself. I know now the definition may be somehow not that much clear, but when we apply in examples, it will be clear. So this is the first approach of the what we call it probability. First conceptual approach of what we call it probability. We have another approach which is called the relative frequency approach. This one where the probability is a proportion of the frequency of a favorable outcome which occurs in a number of observations or experiments. What is the probability? What is the relative frequency approach? Is where the probability is a proportion of the frequency. How frequent something to happen in a number of observation or experiments. So you know, as example, like we have the dice, okay? So if we throw the dice, how frequent is possible to have number 1 in the top of the dice, okay? To see number 1 or to see number 5 or to see number 6. This, when we are studying how frequent is possible, or let's say how frequent is possible to have odd number or to have even number. So this is, we call it a relative frequency approach for the probability. The third approach, which is subjective approach, this one where the probability is a degree of belief an event will occur by an individual based on the evidence and the information provided. So subjective approach is where the probability is the degree of belief, how much I believe that something is gonna to happen by an individual based on the evidence and the information provided. So let's say based on the information provided, how much you believe, that what is the level of your belief that we're gonna find a vaccine for COVID-19 within a month, okay? So this is when you are like using the, when you are calculating the probability of, when you're calculating the degree of belief of something will happen. So this is, we call it a subjective approach because the result of the answers is not always same. It's subjected to the person justification or person idea or person point of view. So again, what are the probability approaches? We have three conceptual approaches. First, The classic approach, where the probability is computed by finding the ratio of the number of possible outcomes included in event A to the number of possible outcomes included in the sample space. The second approach is the relative frequency approach, where the probability is a proportion of the frequency of favorable outcome which occurs in a number of observation or experiments. The third approach is we call it the subjective approach, where the probability is a degree of belief an event will occur by an individual based on the evidence and information provided. So this is somehow a theoretical part about the probability and the definition of different approaches. So let's go a little bit more in detail, because I can understand this type of things is somehow not easy to understand unless we start taking examples. So about the probability, the mathematical theory of probability was first introduced by French mathematician, which is Pascal, and by Fermat when they were trying to solve some gambling problems involving dice, because actually the dice is the most famous thing to calculate the probability. Also the playing cards, because people who are playing in gambling, they are too much concerning about the probability of a specific card to show up or specific number to show in the dice. Because you know the gambling itself is relying 100% on it, on the probability. Because the observer or the person who's trying to gamble or trying to bet on the gambling, he needs to know, or he needs to try to calculate the possibility of a specific number to show based on how the cards are maybe arranged in the hand of the person in charge. So for that reason, so how these things come? It comes from the history of probability, that yes, the two scientist people who were trying to solve some gambling stories, they come up with what we call it probability theory. So the theory of probability has been widely applied in various fields like meteorology, earthquake prediction, some engineering, agriculture, marketing, and finance. Because even probability, it can be applied in finance, because we can use it to predict some future outcomes, because we try to build it based on the historical value, historical data. As example, when now you ask someone, some financial people, about what are their expectations for the economy for coming year. So normally based on the previous historical data, like some data coming from a previous pandemic happened in the countries, and how those countries they were able to react for this pandemic, and what happened after that for economy. They try also to apply some what we call probability things to come up with scenarios, like if these things happen, these things will happen. If the economy react like this, or if the government in the country react like this, so the results will be like this. If they are, so this is all this about scenarios they are giving. It's all relying on the probabilities. So this is what we call it, the historical part about probability, and this theory comes from where? So let's start with the permutations. Permutations are part of the probability. So in the first slide, we're talking about probability itself. What does probability mean? We said is the analysis of the likelihood that an event will happen. We said we have three theoretical approaches, conceptual approaches for the probability. First one is a classic approach. Second one is a relative frequency approach. Third one is a subjective approach. we mentioned or we talk about the history of the probability theory, where does it come from and where it's been used. So now we start with the first part about the probability, which is permutations. So first topic, or like first discussion we're gonna have to talk in the probability is the permutations. What does permutations mean? A permutation is any particular arrangement of R objects, let's say 3, 4, 5 objects, which are selected from a set of n distinct objects. So the permutation is any particular arrangement, any way you do arrangement for a specific number of objects are selected from a group of objects. And always this selected number is less than the number of the group. Let's say I have pens, okay? Just 1 minute. Okay. So let's say I have a group of these pens. As you can see, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. I will remove this one because I've seen. Okay. So we have 8 bands. So the permutation is a particular arrangement of, let's say, 3 bands, which are selected from a group, a set of distinct objects, group of bands. So this, we want to know how we can arrange those 3 bands, which are selected from this group of 8 bands. So this is the R, and the entire group is the N. Okay? So again, what is permutation? Permutation is the arrangement, the particular arrangement of R objects. Let's say 4 objects are selected from a set of distinct objects, from a set of 8 objects. So the 4 objects which are selected is the R, and the entire group is the N. So the formula to determine the number of permutation is as follows. First, where permutation is allowed. When it is allowed to repeat the arrangement or to repeat the item. When it is allowed to repeat the item. So again, we said permutation is a particular arrangement of number of objects or objects which are selected from a set of n distinct. Okay? So to determine this permutation, we have 2 categories or 2 scenarios. First scenario, the repetition is allowed, which means is allowed to repeat the item. So when we have the repetition is allowed, we have n things to choose from, and we have n choices each time. So we have n things to choose from and n times n choices each time. N, which is, let's say here we have 8 items. So when repetition is allowed, so we have 8 items to choose from, and we have 8 choices each time because repetition is allowed. So when choosing all of them, when we select a specific number, 3 of them, the permutation is n times r, n raised to power r. So wait, let me just change this one because should be this one raised to power r. So we said that permutation is any particular arrangement of r objects. Any particular arrangement of R objects are selected from a set of n distinct objects, where R is smaller than n, which is the group of items. The formula to determine the permutation is based on 2 scenarios. First, where repetition is allowed, So we have 10 things to choose. We have 10 things to choose from, and we have n choices each time. So we have 8 things to choose from, and we have 8 choices to each time. So the permutation is r raised to the power n. Sorry, n, which is the number of items, raised to power r, which is how many times or how many things we are selecting. The second thing, which is where repetition is not allowed. The first part we said when the repetition is allowed, we said the items. Let me see whether there is example. So the first thing where repetition is allowed, we said the permutation can be calculated that when we have n things to choose from, we have n choices each time. So let's take one example. Let's take one example because I see here there is no examples. Okay. So here we will use a permutation. And we have that the repetition is allowed. So let's take the example. We have 6 digits, which are 1, 2, 3, 4, 5, and 6. So what is the question? The question is, determine the number of 4-digit numbers that can be formed using the digits given here when repetition is allowed. So the question is, determine the number of 4-digit numbers. How many 4-digit numbers we can create from these 6 digits numbers where repetition is allowed? Okay, how we calculate it? We can say these 6 digits are the n. And what we want 4 digits. So this is the r. So if you remember the previous slide, we said the permutation is n raised to power r. So n is how many digits we have in total. R is how many digits we are looking for in our permutation, in our calculation. So in this example, to answer the question, which is determine the number of 4-digit numbers that can be formed using the digits given if permutation is allowed, is n raised to power r, which is 6 raised to power r, which is 4, which will be equal to, anyone knows equal to how much? 6 raised to power 4. How much?
24.
Are you sure? Yeah, it's 1296. When we say a number raised to power, it doesn't mean the number multiplied by 4. 6 raised to power 4, it doesn't mean that 6 multiplied by 4. It means 6 multiplied by 6 multiplied by 6 multiplied by 6. So this is what does it mean, 6 raised to power 4. So it means we have 1,296 possibility of having 4-digit number out of these 6 digits while repetition is allowed. Okay, so this is example about calculation of permutation when repetition is allowed. So let's go to the second part, which is when repetition is not allowed. So when repetition is not allowed, in this case, we have to reduce the number of available choices each time. So once we select a specific choice, we have to reduce this number and we have to take it out. Okay? So then we will have this formula, which is BR on N divided N minus R, and we have here this exclamation mark. So what does this mark mean when we want to calculate the permutation in this case? So our case is repetition is not allowed. So here we are calculating the permutation, but the repetition is not allowed. So here we need to do this formula, which is N, the exclamation mark here. What does it mean? I'm going to explain to you. Okay, so N, let's say as example, the N is 4. So let's say N, let me just write it for you here. Let's say in our example, N is equal to 4. So when we say N, this is equal to 4 multiplied by 3 multiplied by 2 multiplied by 1. So this sign, this sign it means like this. So when we are giving this example, let's say like if you want to apply this calculation, so N is equal to 4. So N with this sign, it means 4 multiplied by 3 multiplied by 2 multiplied by 1. So let's say that R is 2 as example. So what does this one mean? It means 4 minus 2, this sign, which means 4 minus 2 is 2. So is 2 multiplied by 1. So it's 2. So this is what does it mean by this sign. So another example. So let's suppose that N it's 4. Sorry, N is 6. So when we say N with this sign, so N is equal to 6 as example. So when you say N with this sign, it means 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. As example R, it's 4. So, or let's say as example to not also again go to 1. Oops. Let's say R is 3. So it means N, which is 6 minus 3 with this sign, is equal to 6 minus 3 is 3. Multiply by 2, multiply by 1. So this is what this sign means. Okay, so what does this mean? We use this formula when we want to calculate the permutation where the repetition is allowed. So let's go and take an example. Sorry, this one to calculate the permutation when repetition is not allowed. So let's take example. Consider a number of ways of arranging two letters selected from letters A, B, C, D. So normally the arrangements are like this. A with B, A with C, A with D. If you notice here, we don't have repetition, okay? Then the B, we have A, C, D, then C with A, B, D, then D with A, B, C. So how we can calculate how many possibilities or how many ways we can arrange two letters out of 4 letters. So if we apply our example here, we can see N is the 4, which is the entire numbers. Then R is the how many items we are looking for. So N in our example, N is 4. How many items we want to put together or letters? We need to put 2. So 4 divided on N minus 4 minus 2, then we reach to 12. So again, let's say we have these items, this is those letters A, B, C, D. And we want to know how many, we want to calculate the permutation or how many times we can do 2 letters together. What are the possibilities? So here when we don't want to repeat that, we don't want to put A, okay? Just no repetition. So this we can write it like A with B, C, D, then B with A, C, D, then, okay, but let's consider if you have bigger number, you can't just write it. You have to have a formula to calculate that. So what is a formula? It's based as what we learned is N with this sign divided on N minus R with this sign. So in our example, N is equal to 4. So let's write here, based on our example, N is equal to 4 because we have 4 letters A, B, C, D. R is equal to 2 because we need to arrange 2 letters together. So if we want to put it here, N is equal to 4. So when is N with this sign, it means 4 multiplied by 3 multiplied by 2 multiplied by 1. Divided on N minus R, 4 minus 2 with the sign, which is equal to 4 multiplied by 3 multiplied by 2 multiplied by 1. 4 minus 2 is 2 multiplied by 1. So it will equal to 12. Because 4 multiplied by 3 is 12, multiplied by 2 is 24, divided on 2, which equals to 12. So we have 12 possibilities of having 2 letters arranged together out of 4 letters. Okay? So this is a permutation. We were talking about it, and we said the permutation is any particular arrangement of R objects which are selected from a set of N distinct objects. If you remember, we were giving the example of those bands as example. So the permutation is the any particular arrangement of, let's say, 2 bands out of those 8 bands. So for permutation, we said we have 2 scenarios. First scenario, when the repetition is allowed. So based on that scenario, we have, let's say we have n items on general, then we want to have 2 out of it. So what we put n raised to power r. As an example, we have here, we said we want to calculate the permutation of, we want to calculate the number of 4 digits number that can be formed using the digits given, which are 6 digits if repetition is allowed. Then we said that these 6 digits are the n, the r, which we are looking for because we want item with 4 digits. So r is 4, so repetition is allowed, then the calculation is n raised to power r, which is 6 raised to power 4, which is 1296. And when we said when 6 raised to power 4, it doesn't mean 6 multiplied by 4, it means 6 multiplied by 6 multiplied by 6 multiplied by 6. Then we talk about the permutation when is the repetition is not allowed. So in this case, we have to reduce the number of available choices each time. So we have to apply this calculation or this formula, which is n with this sign divided on n minus r with this sign. So what does it mean n with this sign is, let's say n is 6. So n with this sign is 6 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. N minus r, which is 6 minus 3, which is 3, which is 3 multiplied by 2 multiplied by 1. And then we took an example. Let's consider the number of ways of arranging 2 letters selected from a set of those 4 letters A, B, C, and D. Actually, as it's easy, we can write it then count, but we cannot always write and count because sometimes we have bigger numbers. So we need to apply the formula. We said n is number of items, which are 4, and r how many items we want to select, which are 2. So in our application or in our formula, we said what are the permutation? N is 4, r is 2. So it's 4 multiplied by 3, 2, and 1 divided on 4 minus 2, which is 2 multiplied by 1. Then it will be 12 times. So we have 12 times of doing this item. So if in case the repetition is allowed, so our case here, the repetition is not allowed. So let's calculate if the repetition is allowed. So n we have it is 4 raised to power 2. Okay, so it will equal to 16 times or 16 possibilities. Let me just clear this 16. So is 16. So when the repetition is allowed, we put n raised to power r. So what are those extra 4 items? If you see that when is repetition is not allowed is 12. When repetition allowed is 16. So what are those 4 items extra? If you notice here, we don't have AA. We don't have BB. We don't have CC, and we don't have DD. So those are the 4 extra possibilities, which are the difference between the permutation when the repetition is not allowed and permutation when the repetition is allowed. So this is what we call the permutation. So let's say if you consider only 1 letter is selected from A, B, C, D, then the number of the arrangement is 4 divided on 4 minus 1 with this, with a sign, which means 4 multiplied by 3 multiplied by 2 multiplied by 1 divided on 4 minus 1 with this sign, which means 3 multiplied by 2 multiplied by 1. So it's 24 divided on 6, which is 4. Another possibility, if 3 letters are selected and arranged, then the number of arrangement is 24, because we have the 4 divided on 4 minus 3, which is like 4 multiplied by 3 multiplied by 2 multiplied by 1, divided on 4 minus 3 is 1, so it's nothing, so it's 24. Let's say if we want to select 4 arrangement of those 4 letters, so it's again is 24. This is another example. A doctor has 3 examination rooms. There are 6 patients in the waiting room. In how many different ways can the patients be assigned to the examination rooms? Who can calculate? The question is, a doctor has 3 examination rooms. There are 6 patients in the waiting room. In how many different ways can the patient be assigned to the examination room? So first question, this one, is the repetition allowed or not allowed? In one time. Okay, actually, because a person, he cannot be in 2 rooms in one time. So he can be in first room or second room or third room. This is a normal things. As example, if I ask you, where are you now? So you can tell me in one place. You cannot tell me I'm in KL and Selangor, or you cannot tell me I'm in KL and Nilai. It doesn't work. So the person can be assigned for one place in one time. So the repeat, it's not allowed. So which is R and which is N? N is equal to what? And R is equal to what? So see the example. A doctor has 2 examination rooms. There are 6 patients in the waiting room. In how many different ways can the patients be assigned to the examination rooms? R is 3, N is 6. So let's calculate how many times. It was in N minus R with this one, which means 6 multiplied by, okay, let me just put it somewhere to be able to. So it means 6 multiplied by 5, multiplied by 4, 3, 2, and 1, divided on 6 minus 3, which is 3, which equals to 6, 5, 4, 3, 2, 1, divided and 3, 2, and 1. How much? N is 120. Okay, the answer is 120. We have 120 possibilities, not the N is 120. Okay. Yes. So the possibilities, we have 120 possibilities of assigning 3 patients in 6 rooms. Okay? So this is the solution. Number of patients are 6 patients. Sorry, number of patients is 6, number of rooms is 3. So we have 120 possibilities to assign those patients to these rooms. So let's say we have n objects of which P are alike, Q are alike, and R are alike. The number of permutation can be computed using the following formula. So what does it mean? I'm going to show you. Let's say we have this number of objects. this is the n objects, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Those 10 bands. From those 10 bands, we have those two are similar. And we have those two because those two are for touchpad are similar. So when we want to calculate the permutation, we have to take into consideration that there is some items are similar. Again, what we are calculating now, we are also calculating the probability. Okay? So given n objects, n is a number of items here. So here we have 10 bands. Okay? From those 10 bands, we have those two items are similar. And we have those two items are similar, are alike. So what type of formula we use? We use this formula. So let's take an example. So this example, we will take it about words. So we will have in two stages. First, when the word has no repeated letter. Second, when the word has repeated letter, as we were discussing. Let's say to calculate the amount of permutation of a word, this is as simple as evaluating n, where n is the amount of letters. A 6 letters word has 6 of this one, which is 720 different permutation. When you want to calculate that how many permutation we have a letter of a sentence of 6 letters, so just we calculate like this. So if you want to write it all is possible, but really it's taking a long time. So what we are looking here is to know how many permutations we have. Let's go to the things which we are really concerning about, which is when the word has repeated letter. So we need to apply this formula, which we said is n divided in that the first letter, the sign of the first letter, the second letter, and third letter, how many is repeated. So where n is the amount of letters in the word, and MA, MB, MZ are the occurrences of repeated letters in the word. Each m equal to the amount of times the letter appears in the word. So here, if you notice, we have 2 bands. So each m is 2. Another example is another 2 bands. Is also 2. Let's take example. We have this word, peace. So what is the letter repeated in word peace? Is letter E repeated twice. How many letters we have in word peace? We have 5 letters. So we have the repetition of A, repetition of P, repetition of C is 1 time. But we have the E is repeated twice. So here we are calculating the repetition of each one of the letters. As I mentioned, letter P, letter A, and letter C are repeated 1 time, while letter E is repeated twice. So the amount of permutation of the word peace is 5, which is number of letters, divided on 1, repeated 1 time, repeated 1 time, repeated 1 time, multiplied by repeating 2 times. So it's 5 multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1, divide on 1, multiply by 1, multiply by 1, multiply by 2, which is multiply also by 1 because it's repetition of this number, which will be equal to 60. So how many permutation, how many times we can do the repetition, we can do from this sentence, we can use the letters is 60 times. Let's take another example, word probability. How many different permutations can be formed from word probability? So here we're also calculating permutation. How many different permutations can be formed? So here we didn't limit like whether you want to put 2 letters, 4 letters, 5 letters. We need to calculate how many possibilities, how many permutations we can create from this word. So this word, how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 letters. How many letters are repeated? We have the P repeated twice. We have the I repeated twice. The rest all repeated one time. So the solution, first we have 11 letters. So it's 11, repetition of 11, which is 11 multiplied by 10 multiplied by 9, 8, 7, 6, 5, 4, 3, 2, and 1. Is divided on the how many, like each letter, how many is repeated. So here, why we just put two repeated one time, this one repeat 2 times, and this one repeat 2 times, because each one of those 11 letters is repeated 1 time, excluding of 2 letters repeated twice. So if you put 1 multiplied by 1, it's still 1. And when the 1 multiplied by any number is, will keep 1. So for that reason, we put under here only that numbers or the items are repeated more than 1 because they are effective. So we have the repetition of 2 and repetition of 2, which is 2 multiplied by 1 and multiplied by 2 multiplied by 1. This is the repetition of letter I and the repetition of letter B. Okay. So the result will be 9, 9, 7, 9, 200. This is the number of possibilities, 9 million possibility, 9,979,200 possibilities of permutation, of arranging the letters of word probability. So here, tell me what? Yes, it's this number of probabilities of arranging the letters in word probability, because we didn't set any limitation. We didn't say we want only like 2 letters together or 4 letters together. Then the possibilities will go down, because here we have like possibility of using 1 letter, 2 letters for each one, 3 letters of each one, 4 letters of each one, 5 letters of each one. So here we have 11 letters. So like this, we finish what we call it the permutation. Okay. Let's go to another topic, which is a combination, and which will be our last topic of today's class. A combination is number of ways in selecting R objects from n distinct objects where the order is not important. So the combination is a number of ways in selecting R objects from n distinct objects where the order is not important, so we can use this calculation. So the formula is n, if the repetition of n, repetition of R, n minus R, the repetition. Let's take example. How many ways can a student choose 4 out of 6 questions in an examination? How many ways students can choose 4 out of 6 questions in examination? So n is 6 because we have 6 questions, and R is 4 because you need to select 4 questions. So we have 6 multiplied by 5 multiplied by 4, 3, 2, and 1. 4 repetition of 4 multiplied by repetition of 2, which is 4 multiplied by 3 multiplied by 2 multiplied by 1. Then repetition of 2 multiplied by 2 multiplied by 1. So it's 5 15 possibilities. So how many ways can a student choose? 4 out of 6 of the question. So maybe he choose question 1 with number 1, 2, 3, 4, and those 4. Or 1, 2, 3, and 5. 1, 2, 3, and 6. Or 2, 3, 4, and 5. 2, 3, 4, and 5. 2, 3, 4, and 6. And like this, so we have 15 possibilities of selecting number of questions or combination between the items. Another example, there are 12 people entering a room where there are only 10 chairs. The question, how many ways can 2 people be chosen to remain standing? Again, we have 12 people, so our n is 12. We have 10 chairs. So how many possibilities, how many ways can 2 people chosen to be standing? So here our R is 2, not 10. We are not saying how many possibilities 10 people they will be seated. We are saying how many possibilities of 2 people will be standing. So our R is 2. Our N is 12, so we have 66 ways. We have 66 ways of deciding who are those 2 people they will be standing. Okay, so this is the permutation and combination. So if you remember, when we're talking about permutation, we already decide permutation. We already decide how many items we want to select. So we need to calculate the possibilities of arranging those items. In combination, we want to find the number of ways of selecting those 2 items, or selecting of number of items. Okay. So in the permutation, we already selected number of items. You want to see how many ways those items can be arranged. Here, we want to know how many ways to select those items, to select 2 or 4 items. So any question till now? Okay, so let's continue the last part of today's class, which is the rules of probability, event, and sample space. Sample space is a possible outcomes of an experiment. As example, if we toss a coin, you know the coin, where we have, like, let me see if I have any. Okay. So we have the coin, you know, each coin has 2 sides, right? Each one of, I'm sure you know the coins, like 50 cents, 10 cents. So each coin has 2 sides. And you know that the weight of the coin is divided equally for the both sides, which means when we toss the coin, the possibility to come on the face side or the tail side is similar, because none of the sides is more wet than the second side, because if one of the sides is more wet, so the possibility to go on the wetter side is higher. But The coin is very famous example for what we are talking now. The coin, it has two sides only, and the possibility of the coin to go in one of the sides is equal to the possibility of going in this another side, because both sides are same weight. Okay? If you toss a coin, the possible outcomes are either head or tail. So the sample space is head or tail. S is H or T. So this is what are the sample space, which are like what other possibilities will come. As example, if we have dice, what is the sample size? Sample space. For the dice, what is the sample space? We mentioned for coin, the sample space, either the head or the tail. So the sample space for the coin, head or tail. So for dice, what is the sample space? For dice, what is the sample space? Only 6? Only 6? Yes, is 1 to 6. That's right. 1, 2, 3, 4, 5, and 6. Because you know, the dice has 6 faces. So when we throw the dice, we have the sample space or our sample space. It will show either 1 or 2 or 3 or 4 or 5 or 6. So for coin, we said we have sample size, sample space is either head or tail. For dice, or what we can say the number of elements or possible we can say the number of elements or possible outcomes is 2, and we write n as is 2. The number of elements is 2. If we throw the dice, the possible outcomes is from 1 to 6, 1, 2, 3, 4, or 5 or 6. So the sample space will be n of s, number of possibilities or number of space, which is 6. So an event A is a set of outcomes or a subset of the sample space. A possibility of A denotes the probability. The probability of A denotes the probability of an event A occurring. Then the A with this sign in the top, it denotes the probability of A not occurring. Okay? So again, if the BA, it means the probability of A occurring. So BA with this sign on the top, it's the probability of A not occurring. So the sum of occurring of A and of not occurring of A should always equal to 1. So the sum of occurring a number or not occurring, this possibility or not occurring, when we sum together, we have to reach to number 1. So the probability is expressed as decimal between 0 and 1. If we are certain an event will occur, the probability is 1. Or if there is no chance that event will occur, the probability is 0. Let's take example. If you roll a dice, what is the probability of getting number 5? If you roll a dice, what is the probability of getting number 5? The second question, number less than 4. So let's calculate it. What calculation we use? This is the calculation. So the dice, it has 6 faces and only one face has 5 dots, right? So the frequency of getting 5 is 1. How we calculate it? Because the number of outcomes included in the event divided on the sample size. How many faces of the dice has 5 dots is only 1 face. How many faces for the dice is 6 faces. Again, what we are calculating here, the probability. What is the question? What is the probability of getting number 5? So when we apply this formula, number of outcomes included in the event. How many 5 we have in the dice is 1 5. The sample size, how many faces we have to the dice? 6. So is 1 out of 6 the possibility of having the number 5. The second question is number less than 4. How many numbers in the dice are less than 4? How many numbers in the dice are less than 4? Three numbers. Great. So when we want to apply this one, we want to calculate the second question, which is the possibility, which is what is the probability of getting a number less than 4? So number of outcomes included in the event is 3 because we have 3 numbers less than 4, which are 1, 2, and 3 divided on the sample size, which is 6 because dice has 6 faces. So is equal 1 on 2 is half. Okay, let's go to the coin. How many? If I ask about the coin, what is the probability of getting the head? Let's say coin. The question, what is the probability of getting head? Can you calculate for me using that equation, which is number of outcomes included in the event divided on the sample size. Number of the event included divided on the sample size. Yes, is 1 divided into 2 because in the coin we have 1 head and the sample size is 2 because the coin has 2 faces. So is 1 out of 2. Okay? If you notice, when our sample size is higher, the probability of getting a specific number is lower. You see, like when in the dice, the sample size is 6. So the probability of getting 5 out of 6 is just 1 of 6. In the coin example, we had the sample size is 2. So the probability of getting 1 out of 2 is just 1 out of 2, which is bigger than 1 out of 6. So this is the rules of probability. And this is the possibility of getting 4, which is items less than 4, is 1 out of 2. Additional rule, when we have mutually exclusive events and mutually inclusive events, which means if we select this event, we cannot select another event. As example, if the student want to take some subjects, so maybe we have 2 choices. Either he can choose whatever subject he wants, or if he chooses a specific subject, he cannot choose another subject. So this is the difference between inclusive and exclusive. So what is a mutually exclusive event? When event A and event B cannot occur together. As example, when it cannot happen that you can be in 2 places in one time. Or let's say if you want to travel from KL to Penang. So you have either car, airplane, or train. So you cannot travel a car and airplane together. Like in one time, we cannot be in both places, okay? So this one we call it mutually exclusive events. When event A and event B cannot occur together, they are mutually exclusive. For instance, we have to travel to a place and there are only two choices, either by bus or taxi. It's not possible to go by bus and taxi at the same time. So the event of going by bus and going by taxi are mutually exclusive. To find the probability of event A or event B occurring, we sum up the probability that event A will occur and the event A will occur. So this one, event A, event B, if you notice, they are mutually exclusive, which means if event A happens, event B will not happen. So to find the probability, we have to sum up the probability that event A will occur and the probability that event B will occur. Probability of occurring of event A and probability of occurring of event B. So when we sum up, we reach to the probability of occurring event A or event B. So when you see, I need to show you something. When you see this sign, it means there are mutually exclusive events. If you see A with this sign, which means A and B are mutually inclusive events, which means possible to happen both together. Let's take example about mutually exclusive event. There are 25 students in the class. 5 of them score A, and 10 of them score B, and the others they score C. So if the 5A, 10B, and we have 25, it means 10 score C. And you know, if the student score A, he cannot score B, he cannot score C. He's either scoring A or scoring B or scoring C, which means our events here are mutually exclusive. Again, our example here about mutual exclusive event. You know, if the student score A, he cannot score B and he cannot score C. If he scores B, he cannot score A or C. If he scores C, he cannot score A or B. So it means our events here are mutually exclusive. So if the student is selected in random, what is the probability that the selected student score A or B in calculus? So here, we want to calculate the probability of A exclusive B. So we need just to sum the probability of occurring of each one of it. You see, this is the figures. The probability of A itself is 1 out of 5. So first, to calculate the probability A exclusive of B, so it's probability of occurring of A plus probability of occurring of B. Probability of occurring of A, we go back to our previous formula, which is number of outcomes included divided on the sample size, right? So number of the possibility of occurring divided on the sample size. That A is 5 times. If you remember, we said 5 students, they get A, 10 students, they get C, 10 students, they get a B. So the possibility of occurring A is 5 times, the number of A's is 5 divided on the sample size, which is 25. So the probability of occurring A is 1 out of 5, or 5 divided on 25, which is 1 out of 5. The possibility of occurring B, how many students they have B? There are 10 students. The sample size is 25, so it's 10 divided on 25 is 2 out of 5. then that's a possibility of occurring A exclusive B, when A and B are exclusive, because when the student's having A, he can't be having B. So it's plus or the sum of those two occurrences, which is 1 out of 5 plus 2 out of 5, which is 3 out of 5. So this is the possibility of occurring A or B, because we said A and B are events are exclusive. Let's take the inclusive events to understand the things. First, we said when the items or the events are exclusive, mutually exclusive, which means no way to both of them happen together. So what we do, how to calculate the possibility of occurring this event or this event? We need to sum up the possibility of occurring each one of the events. How to calculate the possibility of occurring of each one of these events? We go back to our previous formula, which is how many times we have this item divided on the sample size. How many times we have students, they have A, they are 5. Sample size is 25, so it's 5 out of, divide on 25, which is 1 out of 5. And then for B, it's we have 10 students, they have B, divide on 25, which is 2 out of 5. So the probability of occurring A or B is 1 out of 5 plus 2 out of 5, which is 3 out of 5. So when our events are mutually inclusive or non-mutually exclusive, okay? Which means event A and event B are non-mutually exclusive. There is possibility that event A and event B will happen. For instance, all students, so first we talk about mark, we said in calculus as example, let's say in business statistics, if any one of you gets A, so he cannot get B or C or D, or he gets B, he cannot get A or C, so either of those. So those are mutually exclusive. But as example, you want to register for this semester, so you have a number of subjects you can to register, either all or some of it, but there is no issue to register one of the subjects and another one. So for instance, all students are allowed to take either mathematics or statistics or both. So either mathematics or statistics or both. This semester, this will result in some of the students taking either mathematics or statistics only, and some of students take both. So how we calculate the probability of those events? Again, those events are non-exclusive, non-mutually exclusive, which means there is possibility that both events happens or one of it happen. In this case, the event of taking mathematics and statistics are non-mutually exclusive. The probability that either event A or event B will happen. So here, if you remember the previous one, they are exclusive, we said A or B. Here we have A or B or A and B together. So the probability that either event A or event B will occur is a sum of probability of event A and event B occurring minus probability event A or B. A and B. So how we can calculate this one? You know how we calculate the... Okay. So A and B, this is when we put this one down, okay? So if you want A or B to happen, again, what we are looking here, also we are looking for A or B. If you want to know that the students get this subject or this subject, but those are mutually to happen. So we need to take probability of A to happen plus probability of B to happen minus probability A and B happen. Let's take the example. This is the sign of non-mutually exclusive. It means there is a possibility A and B happen. Let's take the example. In a business course in a college, 90% of the students passed mathematics. 95 of the students passed management. 88 of the students passed both. So the probability of passing So again, in our question, we have 90% of the students pass mathematics. So probability of passing the mathematics is 90%. And probability of passing the management is 95%. And 88 passed both. So probability of math and management. So you see, I put it here, and management is 88%. So if the student selected at random, what is the probability that student pass mathematics or management? So the student selected in random. So what is the possibility the student pass this one, math or management? So if you want to apply the previous calculation, so we can put statistics or math, whatever. So this is the first one is 0.9, second one is 0.95, and both together is 88%. So if you want to calculate the probability of passing statistics or management is 0.9, which is possibility of passing statistics, plus 0.95, which is possibility of passing management, minus the possibility of passing both of them, because our equation is this or this, which is 0.88. So the result is 0.97. Okay. So we said the probability of this one happen, which is passing statistics or passing management, is probability of passing statistics plus probability of passing business minus probability of passing both. If you notice, this one is or, this one is and. So passing statistics or management is the probability of passing statistics plus probability of passing management minus probability of passing statistics and management. I will modify this one in the slides. So to reach to 0.97. The second part of our question is what? Let me just clear this one. The second part of our question is what is a probability that the student passed neither mathematics nor management, none of both? So if you see, here we calculated if the student passed one of those subjects. If none is the opposite, which is 1 minus passing one of those subjects, 1 minus 0.97, which is 0.03.
If you remember previous class, we talked about the probability, we talked about some examples of it, we talked about the C's and B's and all of this. And also we get exercise last class about the probability. Today, we will continue some rules of probability. We will talk about the multiplication rule. Multiplication rule, here we have two types of multiplication rules based on the events, whether the events are independent or not independent. So when the events are independent, what does it mean? The two events are statistically independent. When the occurrence of one event is not affected, the events are independent when the occurrence of one event is not affected by the result of the other event, which means if one event happened, it's not gonna to affect the occurrence of the second event. As example, If a coin is tossed twice, the probability of getting head in the first event is half. And the probability of getting head in the second toss is also half, no matter what outcome of the first trial. So those two events, which is tossing the coin twice, they are independent event, which means if the first time when I toss the coin, if the first time I get the head, it doesn't mean the second time will be affected with my first result. So if the first time I get head, still the second time I can get head or tail. Even if the first time I get tail, still the second time I can get head or tail. There is no any effect on these two events. They are not affecting each other. They are totally So when the two events A and B are statistically independent, as I mentioned, what does statistically independent means? It means occurrence of one event is not gonna to affect or be affected by occurrence the second event. So the probability that event A and event B will occur is a product of the separate probabilities. So please here keep in mind word and, which means occurrence of A and B. A and B, because those two events are statistically independent, so the probability of happening A and B. You see, this is and. You remember we took this one as or. So this one is and. Okay? So the probability of occurrence A and B is occurrence of A multiplied by occurrence of B. So when this one is applicable, when A and B are statistically independent. What does statistically independent means? It means that occurrence of A is not gonna to affect or be affected by occurrence of B. So A and B are statistically independent. Okay? So this is the important things to keep it in your mind, that A and B are statistically independent. So the occurrence of A and B. So again, when it's like this is and. When it's like this is or. So the occurrence A and B, it's occurrence of A multiplied by occurrence of B when the event A and B are statistically independent. Let's take example. If a couple wants to have 2 children, what is the probability of getting a boy and girl? So the question here, are those events independent or no? Event of getting a boy and event of getting a girl, are those two events independent or no? Again, if couple they want to get kids, so occurrence or probability of occurrence or event of having a boy and event of having a girl, are those two events independent or no? Statistically independent or no? Any answer? Anyone like to answer? Yes, that's right. Yes, are statistically independent, because if they get a boy, it doesn't mean that this one will affect the getting a boy or a girl. If they get the first baby a girl, it has not effect on the occurrence of the second event, which is getting boy or girl. So they can get 2 boys, 2 girls, a boy and girl, a girl and boy. There's no any issue. So those two are statistically independent. Okay. So like this, if you want to get the probability of getting here, what the question is? The question is, what is the probability of getting a boy and a girl? Boy and girl. So let's, if we took probability of B as the probability of having a boy and the probability of G as the probability of having a girl. So we know that probability of having a boy is half, and probability of having a girl is half. Why? Because the two genders are boy and girl. Okay, we have two genders, and the probability of having a boy is 1 out of 2. Probability of having a girl is 1 out of 2. So it means if you want to have a boy and girl, is the probability of having a boy multiplied by probability of having a girl. So it will be half multiplied by half, it will be quarter. So the probability of having a boy and a girl is the probability of having a boy multiplied by probability of having a girl. So it's gonna to be quarter, because it's half multiplied by half is 1 quarter. Okay, this is because those two events are statistically independent, which means occurrence of one event is not gonna to affect or being affected by occurrence of the second event. So this is the first part of the probability, the rules of probability, the multiplication, which, as we mentioned, we have two ways. Either the two events are statistically independent, which means occurrence of one event is not going to affect the occurrence of the second event. And the second type, when the two events are not statistically independent, which means occurrence of one event is going to affect the occurrence of second event. We talk about the first type, which is two events are statistically independent, which means occurrence of first event is not gonna to affect the occurrence of the second event. And we mentioned if you want to calculate the probability of occurrence of first event and second event, so it's just probability of occurrence of first event multiplied by occurrence of the second event. As we took the example here, when if a couple they want to get a boy and girl, so the probability of having a boy and girl is the probability of having a boy multiplied by probability of having a girl. Let's go to the second type of the probability for if our events are not statistically independent, when the occurrence of one event is affected by the occurrence of another event. So the occurrence of one event is affected by the occurrence of another event, which means those two events are not statistically independent, are non-independent event. When this one usually happen in sampling without replacement. This one normally will happen in sampling without replacement. Let's take an example. What is the example? For instance, you want to draw two balls from a bag. This bag contains 3 green balls and 4 black balls. Okay, you want to draw two balls from a bag. This bag contains 3 green balls and 4 black balls. The probability of drawing a green ball is 3 out of 7, because total number of balls is 7, right? The total number of balls is 7. So the probability of drawing or getting the green ball is 3 out of 7, because we have 3 green balls in the bag which has 7 balls. So to get one of the green balls is 3 out of 7, and the possibility of getting a black ball is 4 out of 7. But let's say when no replacement is allowed, given the first ball is black. We took the first ball, so the first ball is black. So for the second time we want to take a ball. What is the probability of getting a green ball? Probability of getting green ball is still 3, but not 3 out of 7, is 3 out of 6, because you already withdraw one ball. Okay, so again, the first way, the first withdrawal, let me just like, yes. For the first withdrawal, we have 3 green balls, we have 4 black balls, okay? So we want to withdraw the first ball. We want to withdraw the first ball. What is the probability of this first ball to be black? We have 4 black balls out of 7. So the probability is 4 out of 7. What is the probability of this ball to be green? We have 3 green balls out of 7, so it's 3 out of 7. Okay? So we withdrew the first ball. First ball was black. So our first ball, let's consider, is black. So now we want to withdraw the second ball. So here what we are saying, there is no replacement. When it means no replacement, it means our events are not statistically independent. They are non-independent, which means the first ball we are withdrawing is gonna to affect the second time. The first event happening, which is withdrawing the first ball, is gonna to affect the second event, which is withdrawing the second ball. Okay? So these things, how it will affect. Let's consider, or let's assume that first ball we withdraw, it's black. So for the second ball you want to withdraw, what is the probability of having black ball? The total of black ball was 4. After we withdraw the first one, it became 3, right? The total balls were 7. We withdraw first one, becomes 6. So the having in the second withdraw to have a black ball is 3 out of 6. To have a green ball not affected. Still 3 green balls, but not out of 7. They are out of 6. So again, the green ball is 3 out of 6. So like this, we can say those two events are non-independent, which means occurrence of the first event, which is withdrawing the first ball, it's gonna to affect the occurrence of the second event, which is withdrawing the second ball. Is it clear? Is it clear, or you have any question? Is it clear? Okay. Okay, so let's continue our class. Where is the class? Huh? Where? Okay, just 1 minute. Okay. Sorry, just like, I don't know what happened to the screen. It's just disappeared. Okay. So that's what I was explaining, the difference between independent and non-independent events for probability. As we mentioned, if our two events are independent, statistically independent, which means occurrence of the first event is not going to affect the occurrence of the second event. So like this, if you want to take event 1, event A, and event B, so how we take the probability of A and B is event A multiplied by a probability of event B. If the events are non-statistically independent or non-independent, as the example here we are having, so how we explain this example, and we said when we can say that two events are non-independent. As the example here, we have like to withdraw 2 balls from a bag. So if we have, like, let's say green balls and black balls, we withdraw the first ball, so we have no replacement. It means the number of the balls in the bag will be less for the second withdrawal, so it's gonna to affect. However, if the first ball is green, so the probability of getting a black ball, it will be 4 out of 6. Probability of getting green ball is 2 out of 6. So when two events, A and B, are non-independent, the probability of A and B occurring is the product of probability of A and the probability of B, given that A has occurred. How we can reflect it here? So this is and as we know. Okay, so probability of A and B is the probability of A and the probability of B, giving that A occurs, or is the probability of B and probability of A, giving that B occurred. How we can calculate? So probability of B, giving that A occurred, is probability of B if the two events are independent. Okay, again, this, what does it mean? This is the probability of B if, or giving that A occurred. Okay, here it's same. This one, it means probability of A giving that B occurred. Okay, so this is how you read this letters. How you read these letters is the probability of A and B is the probability of B multiplied by probability of A, giving that B occurred. Okay, so also we still have multiply if you compare to the previous one when they are independent. When they are independent is the probability of A multiplied by probability of B. This if independent. If they are non-independent, so we will take probability of A multiplied by probability of B if A occur, or probability of B multiplied by probability of A if B occur. Okay, so let's take example. English class consists of 12 male and 18 female students. So as English class consists of 12 male and 18 female students. 3 of the male students and 5 of the female students are non-Bhumiputras. So again, the total number of students is 30. We have 30 students. Those is 30 students, we have 12 male and we have 18 female. Also, we have from those male, we have 5 male and we have, 3 male. Just 1 minute. We have 3 male and we have 5 female. Those are non-Bhumiputra. A student is randomly selected. Find the probability of selecting a non-Bhumiputra student. Probability of selecting a male student given that the student is a non-Bhumiputra, and probability of selecting either a male or a non-Bhumiputra student. So let's discuss one by one. First question is probability of selecting a non-Bhumiputra student. First, let's put some information here. If we put PM is the probability of selecting a male, BF probability of selecting a female, BN probability of selecting non-Bhumiputra, BNM is the probability of selecting non-Bhumiputra and is a male, BNF is the probability of selecting non-Bhumiputra and is a female. So the first question, if you want to calculate those, how we calculate? Probability of selecting a male. If you remember, the total number of male were 12. Total number of students is 30. So probability of selecting a male is 12 out of 30. Probability of selecting non-Bhumiputra. How many non-Bhumiputra we have? If you go back, you will see we have 5 and 3, which means none. 8. We have 8 non-Bumiputra. So the probability of non-Bumiputra is 8 out of 30, right? Probability of selecting a female. If you remember, we have 12 male and we have 18 female out of 30. So 18 out of 30. Probability of selecting non-Bumiputra and the male. How many males non-Bumiputra we have? We have 3 out of 12 because we have 12 non-Bumiputra. Probability of selecting non-Bumiputra and the female is 8 out of okay, just 1 minute. Here I think there is something wrong. Non-Bumiputra. Yes. So here, non-Bumiputra and the male, how many males we have? The total are 12 male. So 3 of them are non-Bumiputra, so 3 out of 12. The probability of selecting non-Bumiputra and the female, we have 18 female, 8 of them are non-Bumiputra. Okay? Non-Bumiputra is actually 5. Right? Yeah, this one is 5, not 8. Non-Bumiputra and female is 5. I will check it now in the break, okay? So this is the things which we have to keep in our mind when we are calculating the requested numbers. Again, the probability of selecting a male, we have the total number of males is 12, the total number of cases or total number of people in our selection area is 30, so 12 out of 30. Probability of selecting non-Bumiputra, we have 8 non-Bumiputra, which are 3 male and 5 female, so 8 out of 30. Probability of selecting a female, we have 18 female and out of 30, so 18 out of 30. Probability of selecting non-Bumiputra and the male, we have 3 non-Bumiputra out of 12. How many males do we have? The total 12. 3 of them are non-Bumiputra. Probability of selecting non-Bumiputra and the female, which is 5 out of 18, because total number of females is 18. How many non-Bumiputra of them is 5? So 5 out of 18. So the first question is, you want to select how many non-Bumiputra. If you remember, A was none. If we select a student randomly, what is the probability to be non-Bumiputra? So is 8 out of 30, because we have total non-Bumiputra 8. The total number of students is 30, so 8 out of 30. Selecting male and non-Bumiputra. Male and non-Bumiputra. So how many non-Bumiputra we have? We have 8. How many males from them? There are 3. You see the difference between probability of male, non-Bumiputra, and the probability of non-Bumiputra male. How many probability of male and non-Bumiputra? Okay. So how many non-Bumiputra we have? We have 8. How many male of them is 3? So probability of having non-Bumiputra and a male. How many male do we have? We have the total is, I remember, was 13, if I'm not mistaken. No, total was 12 male. 12. How many number of male? We have 12. How many non-Bumiputra of those male we have? I remember was 3, right? Yes. So here you need to understand the difference between which one you are applying first, okay? So when we say like probability of male non-Bumiputra, so we take the second number, we put it down, okay? How many non-Bumiputra we have? We have 8. How many male of them? We have 3 male. Probability non-Bumiputra and the male. So how many male we have? 12. How many non-Bumiputra from them? We have 3. So this is the difference when you take which one start first, which one happening first. You are taking male, considering that is non-Bumiputra. So first you have to put the non-Bumiputra and take how many males from them. You are taking non-Bumiputra considering that is a male. So how many males do you have? Then how many non-Bumiputra from them? Okay, so you need to keep this one in your mind. So the second question was having a male considering as is non-Bumiputra. So we break down the non-Bumiputra, then the up is number of males. So we have 3 males out of the non-Bumiputra. Okay. Then the third question was, if you remember, yes, the third question was probability of selecting either male or non-Bumiputra. Do you remember that either and or we take it last class? So let me put you the equation here. So here was either male or, if you remember, non-Bumiputra. Like to calculate this one, we should take a calculate of probability of male, probability of non-Bumiputra minus probability of male and non-Bumiputra. So we have to calculate this one. So probability of male and Bumiputra, if you remember how we will take it, we will take it probability of non-Bumiputra and probability of male considering that is non-Bumiputra or the vice versa. So we already calculated probability of male and non-Bumiputra, 3 out of 8. Probability of non-Bumiputra is 4 out of 15, which we took it, yeah, this one, which is 8 out of 30, if you see this one, probability of non-Bumiputra. So like this, the probability of male and non-Bumiputra is 1 out of 10. So to calculate male or non-Bumiputra, we take probability of male plus probability of non-Bumiputra minus probability of male and non-Bumiputra. The total will be 17 out of 30. Okay. So this is the calculation for probability using the multiplication for 2 types of events. Either those events are independent, which means occurrence of the first event is not going to affect the occurrence of the second event, or the 2 events are non-independent, which means occurrence of the first event is going to affect the occurrence of the second event. We were talking about the probability, and now we want to talk about the tree diagram. Tree diagram is normally used to display the outcomes of an experiment, which consists of series of activities. So this is what we call it, a tree diagram. That this diagram ensures us that all logical possibilities are considered. For example, if a coin is tossed twice, possibility of outcomes are head and head, head and tail, tail and head, tail and tail, right? Because first toss, we can get head or tail. Second toss, we can get also head or tail. So the 4 possibilities we can have here of tossing coin twice is either head and head, which means the first toss is head, second toss is head, or head and tail, which means first toss is head, second toss is tail, or tail and head, which means first toss is tail, second toss is head, or tail and tail, which means first toss is tail, second toss is tail. Using a tree diagram, the possible outcomes can be displayed in the clear way. Can you see here? This is what we call it, a tree diagram. This is what we call it, which you can see here. We call it tree diagram. We start from the first possibilities. First toss, we have half, which is head, also half, which is tail. Second toss, maybe for the first toss we get head, second toss we get head or tail. First toss we get tail, second toss we get head or tail. So if you want to get head and head, so the first line is head for the first toss, head for second toss, so head and head is quarter, is this one multiplied by this one. Then head and tail, first toss is head, second toss is tail, so half multiplied by half is quarter. Tail and head, so it means first toss is tail, second toss is head, is a quarter. Tail and tail, first toss is tail, second toss is tail, is also a quarter. So these are the possibilities which we can get from tree diagram. So we call it a tree diagram. So maybe in the exam, you will be asked to draw a tree diagram of a possibilities of some activities. Okay, this is we call it tree diagram. Let's take example. We have three companies, A, B, and C, are competing for contract to build a condominium. Probabilities that companies A, B, and C will win contracts are 0.25, 0.45, 0.3 respectively, which means probability of the company A to win is 0.25, probability of company B to win is 0.45, probability of company C to win is 0.3. If company A, B, and C win the contract, the probability that they will make profit are 0.8, 0.9, 0.7 respectively, which means that probability of company A to get a profit, if company A get the contract, the probability to get the profit is 0.8, company B 0.9, company C 0.7. Let's draw the tree diagram. The question is construct tree diagram. What is the probability that the companies will make profit? If the contract is found to be profitable, find the probability that the contract was given to company A. So first, the tree diagram. Let's take these words as A is company A, B company B, C company C. U, it means profitable. U with apostrophe here is unprofitable. Okay, so just keep in mind the difference between those icons we are using, or those letters we are using. A, it means company A, company B, company C. U, it means is profitable. U with this apostrophe, it means non-profitable. So this is a tree diagram. First, we have company A, company B, company C. And we took the probability of company A 0.25, 0.45, 0.3 based on our question. Then company A probability to be profitable. So profitable if it's company A. We said is 0.8. Do you remember? We take it in this here. 0.8 probability to be profitable for company A. So non-profitable, well, how much will be? Do you remember last class we took the opposite of? So if it's profitable, the probability to be 0.8. So what is the probability for being non-profitable for company A? If the probability to be profitable for company A is 0.8, so what is the probability for being non-profitable for company A? Anyone can explain? $0.2. Yes, thank you. Okay, so it means we always know when the opposite of, which is 1 minus the probability of occurrence of events. So for that reason, when we are drawing that tree, so this is the first part, which is A, probability of A, probability of B, probability of C. Probability of A to be profitable 0.8, to be non-profitable 0.2, same for B, same for C. So like this, probability of A and probability of being profitable for A is 0.25, 0 multiplied by 0.8. Then the probability of being A and non-profitable for A is 0.25 multiplied by 0.2. Probability of being B and profitable for B, which will be 0.0440, which is 0.45 multiplied by 0.9, and same for the rest. So let's see what are the questions. Second question, the probability that profit will be made for the companies, which means A and profitable, or B and profitable, or C and profitable. How we take it? You remember when we are having or, what we put? Plus. Do you remember that? And we put multiply, or we put plus. So to be A and profitable, 0.2. B and profitable, 0.405. C and profitable, 0.21. Okay? So plus 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 is 815. From where we took this one? We took it from here. You see? Okay? This is the things which we took it. So probability of being A and the profitable, which is A multiplied by profitable for A. This means is the probability of being A and profitable. Sorry, yes. A and profitable, which is A multiplied by being profitable, 0.2. Okay? So being profitable, it means is A and profitable or B and profitable or C and profitable, which is 0.815. Third question, if the contract is found to be profitable, the probability that the contract will be given to company A, which means A and profitable. Okay, so we take the probability of being profitable and probability of being A and profitable. So 0.2 A and profitable multiplied by being profitable, which is 0.815, it will be 0.245. So if the contract is found to be profitable, what is the probability that the contract will be given to company A? So this is the probability of being profitable and probability of being profitable, sorry, and probability of being profitable and given to A. So like this, we can multiply that. What is the probability of being profitable is here. So this is contract found to be profitable. It's same as when we are taking number of non-Bumiputra students. We put it down. Then it's non-Bumiputra and is a male. So we put it up. Okay? So same, we calculate it will be 0.245. For the probability, you need to practice more. You need to know how we are reading the sentence, so which one of the equations we need to apply. More practicing, it will be more helpful for you.